This project is a collaboration between Drexel University's Conquer Collaborative Lab and the MDA ALS Center of Hope at Temple Health in Philadelphia, Pennsylvania. And the project is a neuroergonomic BCI with custom augmented reality display targeting continuous at-home use for people living with ALS. Here are contributors and students. So looking at data from running the BCI with 19 ALS participants in our lab, we found that BCI spelling accuracy decreased as ALS-FRSR score decreased or the disease progressed. So we believe that some of the decreased accuracy seen in our results can be attributed to BCI components and methodology that increase fatigue for ALS users, specifically those at later stages of the disease. So an example of this is having to attend to an external monitor, which can lead to neck and eye strain in order to see the screen. Additionally, many individuals at later stages of the disease are in a lying down position or reclined position, and this warrants the need to have their head propped up, which can be uncomfortable and fatiguing. And then lastly, there are many wired connections and heavy equipment in setup, and this can lead to long setup times, which on top of calibration can be really fatiguing if they have to sit through long sessions in this position. So one of the first ways that we incorporated some new technology is with augmented reality glasses. And so shown here, the screen is displayed right in front of you, and at any position, it is in your eyesight. So this is great for a user that has to lay down or is in a reclined position. So from that design, we moved away from the AR goggles because they can be bulky, heavy, and expensive. And so here we have a more mobile design with custom, lightweight, miniaturized augmented reality glasses. And this uses a 1.8-inch TFT LCD screen. And so overall, this glasses and screen weighs less than 6 ounces. And the cost of these materials excluding the EEG cap, is less than $120, which is way cheaper than most augmented reality goggles on the market. So to achieve a more transparent look like the augmented reality goggles, the back of the LCD screen is taken off on the right here. And this BCI display is ran from OpenVibe, and the entire system is run on Ubuntu on the Raspberry Pi, which is powered by a battery pack. Our next steps involve merging Google Home with our system so that it can also be used for environmental control, and then also getting our systems in the homes of people living with ALS or PALS. And so we really want people at any stage of disease to be able to use our systems for continuous periods of time and really take advantage of the fact that they're mobile, lightweight, and low cost. And so with continuing our collaboration with the MDA ALS Center of Hope, we really hope that we can make a difference in the homes and ability of these people.